Welcome to Betacam SP Studio Recorder's 1000-hour service. This tape and its guidebook is a part of the Ampex Video Instruction Series. Traditionally, if one uses a service manual for maintenance, mechanical topics are difficult to understand. Many procedures are not easy to comprehend from words or diagrams alone. You must see the operations performed to learn them easily. This tape does not replace the service manual. It is a companion. It focuses on the topics that are best presented visually, mechanical issues primarily. It will not include many electronic adjustments, for example. The periodic checks and replacements list in the service manual is the source of most of the topics. They are the 1000-hour items. All are the operations that you most regularly encounter in normal service. The tape also does not include routine cleaning and less frequent replacements. We designed the tape specifically for use while you are actually making adjustments on a machine. You will be instructed by this symbol when to pause and adjust. Do not stop the tape before playing once through the entire section between the stop signs. We will superimpose test and adjustment points on the screen at the stop point. They are also given in the guidebook. The tape contains 7 sections: a quick look at the Betacam format if you're approaching the product for the first time, and 6 detailed procedure sections. You may use the sections individually or in order for a complete alignment. A tape timer appears in the picture at all times and in the guidebook for easy reference. In this section, you will survey the essentials of the Betacam tape format. Mechanically, Betacam is very similar to Betamax, but also resembles other cassette-based systems, such as U-matic. A threading ring wraps the tape slightly more than halfway around the drum. Opposing heads alternately scan the video tracks. One track is equal to one field of video. The essential difference between Betacam and other analog cassette formats is the way video is recorded onto the tape. Betacam is a component video system with separate luminance and chrominance signals. The separated components are recorded simultaneously onto 2 side-by-side tracks by 2 pairs of heads located on opposite sides of the drum. The individual heads in each pair are offset vertically and horizontally. The leading head records the luminance component, the other head the color difference components. The color difference components, R-Y and B-Y, are time multiplexed to form a single chrominance signal. Notice the difference in the azimuth or angle of the head gaps. This prevents crosstalk. Here is a microscopic view of the actual tracks on a Betacam SP tape. Notice the alternating luminance and chrominance tracks and the azimuth difference between the information on adjacent tracks. For every line of video, each color difference signal is time compressed to half a line by an analog or digital delay device. The resulting time compressed signals are then recorded one after the other onto the chrominance track. Therefore, the time compressed color difference information for one line of video occupies the same space on the tape as the uncompressed luminance information on the adjacent track. The color difference components, being smaller in bandwidth than luminance, suffer little degradation in the time compression process. Betacam studio recorders also include 2 additional audio channels recorded along with the chrominance on 2 FM modulated subcarriers. In this section, you will replace the upper drum. You will also center the drum using an eccentricity gauge. 2 screws secure the drum to its mounting flange. With these screws snugged up lightly, you will move the drum until you center it. The eccentricity gauge will indicate how much the drum is off-center as you rotate it slowly by hand. You will move the drum in tiny increments by tapping gently on it with a plastic screwdriver handle. On all Betacam products, in order to repair a single defective video head, you will replace the entire upper drum assembly. Individual heads are not designed for field replacement. The upper drum assembly comes with a factory-aligned record play amplifier matched to the heads. You will begin by removing the transport's top cover. It is held in place by the 2 screws indicated. Stop the tape at this time to remove the cover. To gain easy access to the drum, you are advised to remove the tape elevator assembly. You will do this by lifting the circuit board with the black plastic cover. Catches hold it at the front. 2 captive screws hold the elevator assembly retaining bar in place. You will unplug the white connector. The best way is to lift the back of the tape elevator assembly, slide it backwards until the front is clear. You can then lift it upward. Stop the tape to remove the elevator. You will remove several items being shown on or near the drum. You will need to remove the cleaning roller block. It is held by the 2 screws shown. Stop the tape and remove the cleaning roller. You will remove the plastic slip ring protective cover. It is held by the single screw shown. You will also unplug the red and white connectors on the slip ring assembly. You will use a 7mm nut driver to remove the 2 threaded brass spacers indicated. Stop the tape to remove the slip ring cover, the 2 connectors, and the slip ring assembly. You will remove the drum screws, 4 small ones securing the printed circuit boards, do not lose the washers, and 2 larger ones which attach the drum. Stop the tape to remove the upper drum. Before installing the new upper drum, you will clean the mating surfaces of the flange and the new upper drum with a cloth and cleaning solution. Dirt or finger grease will prevent proper alignment. Stop the tape and clean these surfaces. To install the drum, you will orient the letter A on the flange base to the same side as the A channel of the printed circuit board. The key in the hub will line up with the keyway in the slip rings. You will press the drum downward until it seats. You will then install the 4 small screws and washers that hold the printed circuit board and slip ring contacts in place. If these are not properly tightened, poor or no RF may result. You will install the 2 larger screws that hold the drum. Do not tighten these screws. Merely snug them up lightly. They will be tightened later. Stop the tape to replace the drum. You will now center the new drum and tighten the mounting screws. You will use an eccentricity gauge and fixture. The gauge is normally mounted at the position indicated after removing the existing screw. You may use any alternate mounting location that will position the gauge in the proper relationship to the drum. Stop the tape, locate the normal mounting position, and remove the screw. You will now install the eccentricity gauge and fixture. The tip of the gauge will touch the drum approximately 1/4 inch or 5 millimeters below the top edge of the drum between the first and second grooves. The dial will face away from the drum and the gauge itself will roughly be tangent to the drum. You will rotate the fixture toward the drum until pressure on the plastic tip causes the dial to deflect to approximately half its possible travel. You will then tighten the entire fixture in this position. Stop the tape to install the eccentricity gauge. You will next slowly rotate the drum clockwise, noticing the large deflection of the meter during one revolution. You will eventually reduce this range to 5 microns, or about plus or minus 1 scale division on the meter by moving the drum in small increments. Stop the tape, rotate the drum, and note the deflection during one revolution. Next, you will rotate the drum until the gauge is deflected downward to a maximum. You will then tap on the drum gently at the location shown with a plastic screwdriver handle until the gauge pointer moves to approximately the middle of the deflection range. Again, you will rotate the drum, noting the change in the deflection range. You will repeat the process until the deflection is within specification with the screws tight. The example shown is better than required. Stop the tape and adjust eccentricity. The drum mounting screws must be tight upon completion. Remove the gauge and replace the screw. An alternate eccentricity gauge is manufactured by Tentel. It mounts externally on a fixture and features a fine position adjustment screw. You will now reinstall the slip ring assembly. Do not tighten the screws. Each brush must fall in the appropriate groove and be on the correct side. You will adjust the slip ring assembly until both sets of brushes deflect as shown in the guidebook illustration. You will estimate with a feeler gauge. You will tighten the brass spacers with the brushes in the correct position. Stop the tape to reinstall the slip ring assembly. You will now reconnect the two connectors and replace the plastic cover. Stop the tape to connect the connectors and reinstall the cover. You should replace the sponge cleaning roller at the same time as the upper drum. You will do this by removing the plastic retaining clip at the end of the shaft. You will then be able to slide off the sponge roller and a small brass washer. Another washer and a spring remain on the shaft. Stop the tape and replace the cleaning roller. You will now reinstall the cleaning roller assembly. Do not tighten the mounting screws. The assembly must first be properly positioned. This will be done by depressing the cleaning roller solenoid and moving the assembly until the white plastic pin is located midway between the edges of the metal slot. You will tighten the screws in this position. Stop the tape to install and adjust the cleaning roller assembly. In this section, you will replace the pinch roller assembly. This procedure will be performed in the mode of no cassette in the machine, the unthread mode, with the power off. It will also be advisable to remove the tape elevator. You may refer to the beginning of the upper drum replacement section of this tape. You will begin by rotating the pulleys on the threading ring motor a few turns, until the pinch roller is clear of the threading arm. Stop the tape and turn the threading ring motor a few turns. Remember that the unit will be in the unthread mode. You will remove the retaining clip holding the pinch roller arm onto the pin in the threading ring. You will then lift off the pinch roller assembly and spring. You will normally replace this entire assembly, not just the rubber roller. Stop the tape to remove the pinch roller assembly and spring. To reinstall the new pinch roller assembly, you will first place the spring on the pin oriented as shown. Then you will install the new pinch roller assembly, allowing the end of the spring to remain clear of the arm and the retaining clip. You will be able to push the spring into position under the pinch roller arm. Stop the tape and install the new pinch roller assembly. The pinch roller press block solenoid requires adjustment after installing a new pinch roller. You'll begin by placing a tape cassette, one with the tape door removed, onto the spindles. You will hold the cassette down with a weight and turn the power on. You will wait until the tape fully threads and then turn the power off. Next, you will engage the solenoid with a screwdriver. The gap which opens, as indicated by the feeler gauge, should be 0.7 millimeters plus or minus 0.1 millimeter. You will adjust the gap by loosening the mounting screws. Screwdriver slots are provided to assist in the adjustment. Stop the tape to adjust the pinch roller press block solenoid. Turn the power on. When the tape unthreads, turn the power off. Remove the cassette. In this section, you will make adjustments to establish correct tape tension. You will measure the tension with a spring tension gauge. You will use a handmade tape fixture to provide a non-moving, open-ended length of tape to apply calibrated tension while performing the adjustments. Tension in the tape, generated by the reel motors, is continuously monitored by a spring-loaded tension arm and guide, located ahead of the entrance guide. You will make both mechanical and electrical adjustments to calibrate the tension servo system. You will now place the SV83 board on extender. Then you'll turn the unit on and remove any cassette. You will connect a voltmeter's positive lead, here shown red, to TP1. You will adjust RV1 for 9 volts DC plus or minus 0.1 volt. Be sure the unit has been on for at least 30 seconds before making this adjustment. Stop the tape to attach the voltmeter to TP1 and adjust RV1 for a reading of 9 volts. The voltmeter will now be moved to TP3. You will place a shorting clip, here shown yellow, between TP4 and TP5. You will adjust RV2 for a reading of 2.5 volts DC plus or minus 0.04 volts. Stop the tape, attach the voltmeter to TP3, a shorting clip between TP4 and 5, and adjust RV2 for a reading of 2.5 volts. Using about 16 inches or 40 centimeters of half-inch videotape, you will construct a test fixture similar to the one shown. You'll fold back the ends of the tape, reinforce the ends with cellophane tape, and punch a hole. You will then tie a short length of string in a loop through each hole. You will then install the tape test fixture as shown. The tape passes between the tension regulator arm guide and out in front of guides 1 and 2. Across in front of the drum to the guide shown, and then forward toward the front of the unit. The tape then passes out of the unit through the cassette insertion slot, and the string loop is attached to a tension scale. You will pull on the tape with the scale to create and read tension. Stop the tape, leave the power on, and install the test tape fixture and tension scale. You will position yourself near the right front corner of the unit. Then you'll pull on the tape fixture to help locate the tension regulator arm. It is the part moving here. You'll then locate the gap that develops between the tension arm and the black rubber stop. It is seen here near the point of the screwdriver. Stop the tape and locate the gap. You will now apply a tension of 45 grams. A gap of 1.4 millimeters plus or minus 0.2 millimeters should open between the tension arm and the rubber stop. If not, you will loosen the mounting screw and adjust the gap. A 1.5 millimeter hex wrench will assist you in estimating the gap. Stop the tape and adjust the gap. Retighten the mounting screw. You will now attach the voltmeter to TP3 on the SV83 board. Then you will loosen the mounting screw on the TR18 board. Stop the tape to attach the voltmeter to TP3 and to loosen the mounting screw on the TR18 board. Maintaining a tape tension of 45 grams, you will move the TR18 board until the voltmeter reads 2.5 volts DC plus or minus 0.03 volts. Screwdriver slots are provided to assist in this adjustment. Stop the tape to adjust the position of the TR18 board for a reading of 2.5 volts on the voltmeter. Retighten the screw. You will now apply a tension of 25 grams and adjust RV3 for a reading of between 1.71 to 1.73 volts DC on the voltmeter. Stop the tape and adjust RV3 for a reading of between 1.71 and 1.73 volts on the voltmeter. Note, this and the previous procedure are interactive. Reconfirm that both are correct before proceeding. In this section, you will perform the adjustments that allow a recording made on one machine to play back correctly on another. The process is called tracking or interchange. A machine properly adjusted for tracking interchange places the recorded tracks in the correct position on the tape. You will adjust tape guides until the tape passes around the drum in a straight and accurately positioned path. You will make adjustments to place the tracking control at the center of its range when the off-tape signal is at maximum amplitude. You will also correctly position the audio, timecode, and control track heads. The tape is guided into a correct path around the drum by 6 guides, 3 on the entrance side and 3 on the exit side. On the entrance side, the correct track is established by slight pressure on the top of the tape at the tension arm guide, on the bottom of the tape at guide TG1, and on the top of the tape at the entrance guide TG2. Likewise, on the exit side, the exit guide TG3 and guide TG4 exert similar guiding pressures on the tape. Stop the tape and locate the 6 guides. Refer to the drawing in the guidebook. You will now place a CR2 1B alignment tape on the take-up spindles and hold it down with a weight. You will place the unit into play mode. You will use an inspection mirror to verify visually that the tape correctly passes over all 6 guides without wrinkling and just touches the appropriate guides on the correct side. A gap, as shown here, or edge curl, as shown here, indicates incorrect adjustment of a guide. Stop the tape and visually inspect the entire tape path around the drum. Do this both in normal play mode and in reverse play mode. Refer to the diagram in the guidebook for guide locations. If, in the previous inspection, the overall tape path does not meet the requirements, the problems must be corrected before proper tracking interchange can be established. You will lock and unlock guides by using a 0.89 millimeter hex wrench in the set screw at the top of the guide and adjust by turning the larger slotted ring with a flat-bladed screwdriver. Clockwise rotation will move the guide downward. Normally, Only the entrance and exit guides will require adjustment during the vast majority of maintenance situations. Refer to the unit's service manual as well if more than the entrance and exit guides require adjustment. Stop the tape and adjust any of the 6 guides if required. Otherwise, proceed to the next step for fine adjustment of entrance and exit guides only. You will now connect an oscilloscope, channel 1 to TP30, and trigger to TP26. Gain 200 millivolts, sweep 5 milliseconds. Throughout this tape, you will use times 10 probes for signals, times 1 probes for triggering. You will turn DT AST off. You will turn on bit 4 S101 on the SV82 board and S1 on the SV83 board. You will adjust entrance and exit guides by observing the RF envelope, TP30, as you rock the tracking control back and forth through the point of maximum RF. And notice how the RF envelope changes shape. This is normal. Stop the tape, connect the scope, channel 1 to TP30, trigger to TP26, and observe the RF envelope as you rock the tracking knob. Turn the DT AST off. If, for example, the entrance guide is too high or too low, the RF will pitch up and down on the left side like this, as you rock the tracking control back and forth through the point of maximum RF. If, on the other hand, the exit guide is too high or too low, the right end of the envelope will pitch up and down like this. If either or both ends of the RF envelope exhibit this type of pitching, you will need to adjust the appropriate guide. When entrance and exit guides are properly adjusted, the RF envelope will expand and contract with no more than about 10% amplitude change along its length. To adjust guides, you will use a .89 mm hex wrench and a small flat-bladed screwdriver. Alternately, a special combined tool is available for performing guide adjustments more conveniently. Some useful tips. First, move in small increments. The adjustment is sensitive. Loosen the set screw, move the slotted ring a little, retighten the set screw. Then evaluate the result by rocking the tracking control. Also, adjust only one guide at a time. Do not have more than one guide loose at the same time. Lastly, the best general guide adjustment procedure is to work with the tracking knob set slightly off track to about the 2 o'clock or 10 o'clock position. Then, with the set screw loosened and the tape playing, you will rotate the adjusting ring slowly while observing the RF envelope. Notice this example carefully. The tracking knob is slightly offset and the adjusting ring is being turned back and forth through the point of correct height adjustment. By repeatedly adjusting with the tracking slightly offset while rocking the tracking control, you will be able to obtain a correct adjustment of guide height. Stop the tape and adjust the entrance and exit guides as required. Several attempts will normally be required. Remember to rock the tracking control when evaluating your adjustments. You will now adjust the tracking control centering. You will play back the alignment tape with the DT AST switch off and the confidence switch off. You will now place the SV84 board on extender and connect the oscilloscope probes, channel 1 to TP102, channel 2 to TP101. Trigger the scope from channel 1, TP102. Gain, channel 1, 2 volts, channel 2, 5 volts. Sweep, 0.1 milliseconds, delayed. On the SV82 board, you will adjust RV102 until the falling edge of channel 2 is coincident with the rising edge of channel 1 by plus or minus 0.1 milliseconds. If the waveform fluctuates, measure from the center of the fluctuation. Stop the tape, connect the scope probes to TP102 and TP101, and adjust RV102 on the SV82 board for the required waveform. You will now adjust the position of the control track head. Notice the location of the switches on the top edge of the SV82 and the SV83 boards. On the SV82 board, you will turn on the dip switch bit 4, and on the SV83 board, switch S1. Stop the tape and set the switches. You will connect the oscilloscope channel 1 to TP30, trigger to TP26, gain 200 millivolts, sweep 5 milliseconds. Stop the tape and connect the scope. You will now play back the alignment tape. While observing the envelope waveform, you will rock the tracking control through its center detent position. Maximum RF amplitude should coincide with the center detent position. If not, you will loosen the control track head securing screw and move the head with a flat-bladed screwdriver in the slots. Again, you will observe the waveform while rocking the tracking control, and will repeat the process until maximum RF occurs at the center detent position. You will then tighten the control track head securing screw. Stop the tape and adjust the position of the control track head if required. Restore the switches on the SV82 and SV83 boards when finished. Next, you will adjust the position of the audio timecode head. To gain access, you will remove the cleaning roller assembly. It is held by 2 screws. Stop the tape and remove the cleaning roller assembly. You will now place the SV84 board on extender. Then you will connect the oscilloscope channel 1 to TP101 SV84 board, channel 2 TP207 TC40 board, trigger on channel 1. With the alignment tape playing back, you will set the oscilloscope sweep to 5 milliseconds, channel 1 gain to 5 volts, channel 2 gain to 100 millivolts. Channel 2 trace on top. To move the audio head, you will loosen the securing screws and use a flat-bladed screwdriver in the slots to assist you in making the adjustment. You will move the audio head until the rising edge of the channel 1 trace is coincident with the falling edge of the channel 2 trace, plus or minus 400 microseconds. Stop the tape and adjust the position of the audio head if required. Tighten the securing screws when finished. You will now adjust RP head luminance and chrominance switching positions. First, the luminance. On the SV82 board, you will turn S102 bit 4 on. On the SV83 board, you will turn S1 on. Stop the tape and set the switches. You will place the SV83 board on the extender. Notice the positions of RV201, 202, and 206. You will connect the oscilloscope to the DM56 board, channel 1 to TP26, and channel 2 to TP30. Trigger on TP26, channel 1. Stop the tape, extend the SV83 board, and connect the probes to TP30 and TP26 on the DM56 board. Gain channel 1, 0.5 volts, channel 2, 50 millivolts, sweep 50 microseconds, delayed. You will play back the CR2 1B alignment tape. With the scope on positive sweep trigger, you will adjust RV201 for minimum RF gap while centering the switching edge in the gap. On negative sweep trigger, you will adjust RV202. Then you will fine adjust either RV for no phase difference between edges while switching sweep trigger polarity. Stop the tape and adjust RV201 and RV202. Then perform the fine adjustment while switching the polarity of the sweep trigger. You will now perform the picture splitting compensation adjustment. Refer to the diagram in the guidebook. For this adjustment, you will need an external generator with both composite video and composite sync outputs. You will connect composite video to the reference input of the tape machine, loop it through to the video input, and terminate it. Color bars or black is suitable. Stop the tape and connect composite video from the external generator to the tape machine's external reference input, loop it through, and terminate it at the video input. You will also need a video picture monitor, externally referenced to composite sync from the generator. Not all monitors work well. You may need to experiment. You will also need a DOB-NC cable connected to the dub out jack. The guidebook gives the part number for this cable, or you may construct one from half of a spare standard dub cable. You will connect the black lead of this cable to the video input of the picture monitor and terminate it. Also, you must ground the single blue wire in the cable. This forces the DMOD output to the monitor. Stop the tape and connect the external generator and picture monitor. Refer to the diagram in the guidebook. You will now place the SV84 board on extender. Locate RV100 and RV101. Also, you will place the picture monitor on underscan and horizontal delay in order to see the horizontal interval. Stop the tape. Place the SV84 board on extender, locate RV100 and 101, and adjust the monitor for underscan and horizontal delay. You will then turn RV101 fully clockwise. This will maximize the picture splitting error for adjustment, as shown here. Next, you will play the color bar portion of the alignment tape. You will then adjust RV100 until the sync crossover point takes place mid-picture, allowing for the TBC advanced vertical. Here the crossover point is moving up and down as RV100 is turned. Horizontal jitter is normal. Here the sync crossover is shown correctly adjusted. Stop the tape, play back the color bars portion of the alignment tape, adjust RV101 fully clockwise, adjust RV100 until the sync crossover point is correctly positioned. Now, with the tape still playing, you will adjust RV101 until the error is minimized as shown here. The jittering vertical lines will be roughly parallel. Stop the tape and adjust RV101 for minimum error. Return the machine to normal afterwards. In this section, you will adjust the DT-AST system. Before doing so, however, you will perform a minimum subset of the DM56 board adjustments. The complete procedure can be found in Section 12 of the service manual. From experience, the complete procedure is only required if the factory settings of the DM56 board have been altered in service. You will optimize the record current for maximum RF on playback. You will perform video gain and frequency response adjustments mostly on the DM56 board. You will now do record current optimization. There are separate adjustments for both sets of heads, for both the luminance and the chrominance channels, and for both metal and oxide tapes. 8 adjustments in all. All are virtually identical except for test points and pot numbers. Refer to the guidebook. The pots are located on the RP29 board, under the black plastic cover on the hinged lid near the cassette elevator. For this example, you will connect the oscilloscope to the DM56 board, channel 1 to TP30, and channel 2 trigger to TP26. Refer to the manual for the test points for the other adjustments. Channel 1 gain will be set to 0.5 volts, sweep 5 milliseconds. Stop the tape and connect the scope to TP30 and TP26 on the DM56 board. You will use a normal work tape in full record mode with a composite video signal such as color bars. You will place the unit into confidence mode to monitor playback RF during the adjustment. In all the adjustments, as you rotate the pot clockwise, as shown here, the RF will rise to a maximum, remain briefly at the maximum, and then diminish. The correct adjustment is obtained when the pot is turned as far counterclockwise as possible while maintaining maximum RF. Stop the tape, place the unit into record and into the confidence mode on a metal work tape and adjust RV1 for maximum RF. Repeat the process for the other adjustments. Refer to the guidebook. You will now perform a series of adjustments to set up the luminance channels for playback. You will place the DM56 board on the extender and connect the oscilloscope trigger to TP26. You will also use the flat field portion of the alignment tape for the first 3 adjustments. You will also adjust the tracking control for maximum RF playback. Stop the tape, place the DM56 board on extender, and connect the oscilloscope to TP26. You will now adjust the luminance RF level. You will turn DT-AST off. You will turn RV39 and RV40 fully counterclockwise. You will connect the oscilloscope first to TP1 and for the next adjustment to TP2. Gain 0.5 volts, sweep 5 milliseconds. Or you may use dual trace. For clarity, only one channel is shown. With the alignment tape playing, you will adjust RV34 channel A luminance, TP1, and RV35 channel B luminance, TP2, for 0.5 volts DC below ground, plus or minus 0.04 volts DC. Stop the tape, connect the scope, and adjust RV34 and 35, DT, AST off, RV39 and 40 fully counterclockwise. You will move the scope to TP6. You will then adjust RV3 and RV4 for 1 volt plus or minus 0.04 volts. Both are visible on the same scope trace. Here RV3 is being turned back and forth. This is the correct adjustment. Stop the tape, connect the scope to TP6 and adjust RV3 and 4. You will now turn the DT-AST switch to variable and adjust RV1 and 2 for 1 volt as before. Stop the tape, turn DT-AST to variable, and adjust RV1 and 2. You will now perform a luminance frequency response check. You will turn bit 2 S101 on the SV82 board on, and bit 2 S201 on the DT13 board on. You will turn the DT-AST switch off. You will connect the scope to TP3. Use a short probe ground wire connected close to the TP. Gain 1 volt, sweep 5 milliseconds. Stop the tape, turn on the board switches, and connect the scope. You will play back the RF sweep signal on the alignment tape. You will also adjust the tracking control for maximum RF playback. Your waveform should resemble this waveform. Specifications are given in the guidebook. Large errors can only be corrected by upper drum replacement. Stop the tape and perform the check. You will now turn the DT-AST switch to variable. For this adjustment, you will adjust RV39 and RV40 to most closely approximate this waveform. Stop the tape, switch the DT-AST switch to variable, and perform the adjustment. Turn the board switches off when finished. You will now adjust luminance RF AGC output. You will connect the scope to TP7. Gain 0.5 volts, sweep 5 milliseconds. You will play back the flat field portion of the alignment tape. You will then adjust RV11 for 1 volt plus or minus 0.04 volts. Stop the tape, connect the scope, and perform the adjustment. You will now perform a series of adjustments to set up the chrominance channels for playback. These adjustments are very similar to the luminance channel adjustments you have just finished. You will place the DM56 board on the extender and connect the oscilloscope trigger to TP317. You will also use the flat field portion of the alignment tape for the first 3 adjustments. You will also adjust the tracking control for maximum RF playback. Stop the tape, place the DM56 on extender, and connect the oscilloscope trigger to TP317. You will now adjust the chrominance RF level. You will turn DT-AST off. You will connect the oscilloscope first to TP301 and for the next adjustment to TP302. Gain 0.5 volts, sweep 5 milliseconds. Or you may use dual trace. For clarity, only one channel is shown. With the alignment tape playing, you will now adjust RV322, channel A chrominance, TP301, and RV323, channel B chrominance, TP302, so that the DC level of the waveform is 0 volts plus or minus 0.04 volts. Stop the tape, connect the scope, and adjust RV322 and 323. DT-AST off. You will move the oscilloscope to TP304. You will then adjust RV302 and RV304 for 1 volt plus or minus 0.04 volts. Both are visible on the same scope trace. This is the correct adjustment. Stop the tape, connect the scope to TP304, and adjust RV302 and 304. You will now turn the DT-AST switch to variable and adjust RV301 and 303 for 1 volt as before. Stop the tape, turn DT-AST to variable, and adjust RV301 and 303. You will now perform a chrominance frequency response check. You will turn bit 2 S101 on the SV82 board on and bit 2 S201 on the DT13 board on. You will turn the DT-AST switch off. You will connect the scope to TP303. Use a short scope ground wire connected close to the TP. gain 1 volt, sweep 5 milliseconds. Stop the tape, turn on the board switches, and connect the scope. You will play back the RF sweep signal on the alignment tape. You will also adjust the tracking control for maximum RF playback. Your waveform should resemble this waveform. Specifications are given in the guidebook. Large errors can only be corrected by upper drum replacement. Stop the tape and perform the check. You will now turn the DT-AST switch to variable. As before, your waveform should closely approximate this waveform. Stop the tape, switch DT-AST switch to variable, and perform the check. Turn the board switches off when finished. You will now adjust chrominance RF AGC output. You will connect the scope to TP305, gain 0.5 volts, sweep 5 milliseconds. You will play back the flat field portion of the alignment tape. You will then adjust RV311 for 1 volt plus or minus 0.04 volts. Stop the tape, connect the scope, and perform the adjustments. You will now adjust the DT-AST system. If DT-AST performs well after drum replacement, and if settings have not been altered during service, you may decide that a check of these will be sufficient. Before performing this series of adjustments, you will turn off, open, all sections of S201 on the DT13 board and all sections of S101 on the SV82 board. Stop the tape and turn all these switches off. You will now adjust the drive waveform limiter. You will remove the red slip ring connector. You will place the DT13 board on the extender. You will turn RV205 and 206 on the DT13 board fully counterclockwise. You will turn on bit 2 S201 on the DT13 board. Stop the tape, remove the slip ring connector, place DT13 on extender, and turn RV205 and 206 on the DT13 fully counterclockwise and bit 2 S201 on. You will connect the oscilloscope to the DT15 board. It is located in the metal box to the left of the drum. Connect channel 1 to TP10, right terminal, and channel 2 to TP8, middle terminal. Gain 50 volts, sweep 5 milliseconds. Trigger on TP10, channel 1. You will adjust RV2 on the DT15 board for 200 volts either side of DC ground. This is an important adjustment, as too much level can cause DT-AST instability. Both traces must be very much the same. Only one is shown for clarity. It will be necessary to press S202 on the DT13 board to make this adjustment. It remains active for 30 seconds. D305 lights up. Stop the tape, connect the scope, and adjust RV2 for the correct waveform. Remember to press S202 on the DT13 board. You will now perform the distortion erasure waveform tentative adjustment. Using the same setup as before, you will adjust RV205, channel A, and RV206, channel B, for 400 volts peak to peak, plus or minus 30 volts. The correct adjustment is just below clipping. Stop the tape and adjust RV205 and 206 for the correct waveform. Remember to press S202. Afterwards, reconnect the slip ring connector and turn bit 2 S201 off. You will now perform the strain gauge loop gain adjustment for both heads. Only channel A will be shown. Channel B is identical except for test and adjustment points. Refer to the guidebook. You will begin by turning S1 on the DT14 board on and bit 1 S201 on the DT13 board on. You will set RV2 and RV3 on the DT14 board to the position shown. They will be readjusted in a later section. Stop the tape and perform these settings. You will connect the scope channel 1 to TP6 on the DT14 board and channel 2 to TP5. Trigger TP202. You will set the scope gain 200 millivolts, sweep 5 milliseconds. You will invert channel 2 and place the scope into the add mode. Also, channel 2 gain will be used in the variable or uncalibrated mode during the adjustment. Stop the tape and connect the scope. Remember to place channel 2 into the add and invert mode and set the gain to variable. Throughout these adjustments, you will play back the color bars portion of the test tape in the jog mode. Also, the DT-AST switch should be in the variable position. After you have these conditions established and have obtained a waveform on your scope similar to this one, you will first adjust channel 2 gain on the scope until the top of the waveform is horizontal. You will then adjust the jog knob until the left spike is longer than the right spike and is adjacent to the left of the longer horizontal portion of the waveform. Stop the tape and obtain the correct waveform. The setup for this adjustment is the most difficult part. You will now adjust RV5 on the DT14 board. This establishes the correct loop gain for the DT-AST system. When you adjust RV5, the top of the waveform will not remain horizontal. You will have to simultaneously adjust channel 2 scope gain throughout this adjustment to keep the trace level. Your objective will be to set RV5 until there is no undershoot, as shown here, on the left end of the larger horizontal portion of the trace, or no overshoot as shown here. This is the correct adjustment. Stop the tape and perform the adjustment. You may need to occasionally readjust the jog knob. Repeating the entire process once or twice is also recommended. You will now adjust for the other head, channel B. The only difference will be to move the scope leads, channel 1 to TP7 and channel 2 to TP4. You will adjust RV4. Stop the tape, reconnect the scope, and perform the adjustment. You will now adjust the inclination correction gain. You will use the same setup as before, except that you will use only one channel of the scope connected to TP10 on the DT14 board. You will play back the color bars portion of the test tape, alternately in reverse ×1 mode and in forward ×2 mode. You will adjust RV2 and RV3 on the DT14 board so that the tops of the waveform remain level. Here is the correct waveform as the shuttle knob changes the tape direction. Here is channel A being misadjusted, and now channel B being misadjusted. Stop the tape, connect the scope, channel 1 to TP10, and adjust RV2 and 3 for the correct waveform. You will now adjust the sync switching pulse. Leaving the switches set as before, you will place both the DT14 and the SV83 board on extenders. You will connect the scope channel 1 to TP301 and channel 2 to TP202 on the DT14 board. Trigger on channel 2. Gain, channel 1, 500 millivolts, channel 2, 5 volts. Sweep, 50 microseconds. You will use delayed sweep to see only the vertical interval. You will play back the color bars portion of the test tape. Stop the tape, connect the scope, and obtain this waveform. You will perform two nearly identical adjustments by switching the slope of the scope trigger from negative to positive. When you do, you will move from the falling edge to the rising edge on channel 2. You will adjust RV203 and RV204 on the SV83 board. A cut-off adjustment tool is recommended for this adjustment. With the scope on positive slope trigger, you will adjust RV203 until the edge on channel 2 trace is 5H from the start of vertical sync, plus or minus roughly 1/10 H. You will then switch the slope of the scope trigger and adjust RV204 on the SV83 board in the same way. Stop the tape and adjust RV203 and 204. Remember to switch the scope trigger slope between adjustments. You will now adjust DT-AST vertical timing. You will connect the oscilloscope channel 1 to TP301 and channel 2 to TP306 on the DT14 board. Gain, channel 1, 200 millivolts, channel 2, 5 volts. Sweep, 10 microseconds. Use delayed sweep to see the end of the vertical sync pulse. Using the same setup and color bars portion of the test tape as before, you will adjust RV304 on the DT14 board until the rising edge of the channel 2 pulse occurs 16 microseconds before the leading negative edge of the first post-equalizing pulse at the end of the vertical sync pulse, plus or minus 1 microsecond. Stop the tape, connect the scope, adjust RV304 for the correct timing. You will now adjust the DT-AST head luminance switching position. You will place a shorting clip between TP11 and ground on the DT14 board. You will connect the oscilloscope on the DM56 board, channel 1 to TP30 and channel 2 to TP26. Trigger on TP26, channel 2. Gain, channel 1, 2 volts, channel 2, 200 millivolts, sweep, 20 microseconds. Use delayed sweep. Stop the tape, connect the scope to TP30 and TP26 on the DM56 board, and place a shorting clip between TP11 and ground. You will then play back the alignment tape and adjust RV203 on the DT14 board until the gap is minimized to less than 20 microseconds. You will next check the gap at the other end of the track to see that it is also less than 20 microseconds. Do not be confused by the large dropout in the middle of the track, indicating channel B playback. Stop the tape and adjust RV203 for minimum gap at both ends of the track. You will now perform the anti-rolling adjustment. You will connect the oscilloscope channel 1 to TP308, channel 2 to TP301, and trigger to TP202 on the DT14 board. Gain, channel 1, 5 volts, channel 2, 500 millivolts. Sweep, 10 microseconds. Use delayed sweep to view the rising edge on the channel 1 trace. You will place a shorting clip between TP305 and ground on the DT14 board. Stop the tape and connect the scope to TP308 and 301. Trigger TP202 and place a shorting clip TP305 to ground. Using the same setup as before, you will play back the color bars portion of the test tape in the still mode. You will alternately ground and unground the shorting clip on TP305. When you do, if the rising edge on channel 1 moves more than roughly about half an H, you will adjust RV305 on the DT14 board to minimize it. Stop the tape and adjust RV305 while grounding and ungrounding TP304 on the DT14 board. Afterwards, remove the shorting clip. You will now perform the distortion erasure waveform offset adjustment. You will remove the cassette from the machine. You will connect a DC voltmeter first to TP10 and then to TP8 on the DT15 board. Be careful not to short the probes to the case. You will adjust RV6 and RV7 on the DT14 board for channel A and channel B. You will adjust both until the DC offset is reduced to 0 volts, plus or minus 0.5 volts DC. Stop the tape and adjust RV6 and 7 on the DT14 board for 0 volts DC at TP10 and TP8 on the DT15 board. In this final DT-AST procedure, you will repeat the distortion erasure waveform adjustment. You will turn on bit 2 S201 on the DT13 board. You will connect the oscilloscope to the DT15 board, channel 1 to TP10 right terminal, and channel 2 to TP8 middle terminal. Gain 50 volts, sweep 5 milliseconds. Trigger on TP10, channel 1. You will adjust RV205 and 206 on the DT13 board for 190 volts either side of DC ground, plus or minus 5 volts. Be sure the waveforms do not enter clipping. If they do, you will need to repeat the drive waveform limiter adjustment at the beginning of the DT-AST procedures. It will be necessary to press S202 on the DT13 board to make this adjustment. It remains active for 30 seconds. D305 lights up. Stop the tape, connect the scope, and adjust RV205 and 206 on the DT13 board for the correct waveform. Remember to press S202. This now concludes Betacam 1000-hour service. In completing this training package, you have replaced and aligned the upper drum and pinch roller. You have established correct tape tension and have adjusted the unit's servo systems. You have aligned tape guides to provide proper machine-to-machine tracking, interchange, and you have adjusted the unit's DT-AST system. These are the procedures you will regularly encounter in routine service. For less frequent replacements and adjustments, you should refer to the unit's service manual. This has been a production of Ampex Training.